We're now going to go through the exponential base graphs. And actually, the kind of things I've done here are exponential base graphs. Ooh, isn't that funky? But we don't know that yet, so let's figure it out. So I've kind of pre-printed a table for myself here because I didn't feel like writing the whole thing out. And what we're going to do is we're going to be filling it in. So way over here, I'm not sure if it's visible. Maybe I should just do it a bit big. So let's say we have f of x equals 2 to the x. And we're going to make a table of values, x and y. And we'll do it for minus 3, minus 2, 1, 0, 1, 2, and 3. So, what would the values be? Let's start with 3, because I think actually that's probably the easier one in all of these. Let's make it an actual table. So 2 to the 3 is 8. 2 to the 2 is 4. 2 to the 1 is 2. 2 to the 0, as you may or may not recall, is actually 1. 2 to the negative 1, when you have negatives, it becomes 2 to the negative 1 is the same thing as 1 over 2 to the 1. So that's 1 over 2, which is 0.5 if that matters. This is 2 to the minus 2, which is 1 over 2 to the 2, which is 1 over 4, which is 0.25. And similarly, this one ends up being 1 over 8, or 0.125. So, if we were going to graph this thing, let's put this on our grid like I usually do. So we know that we have a point. Here's the point. When x is 3, y is 8. When x is 3, y is 8. When x is 2, y is 4. When x is 1, y is 2. When x is 0, it's 1. When it's negative 1, when x is negative 1, the y is 0.5, or about halfway. And then it becomes 0.25, and then like that. And it just keeps on getting smaller and smaller, closer to the 0. 4, by the way, is 16, which is way above over there. Now, if I was going to draw this thing, it's not that easy to draw. It's going to look something like that. And that's what the graph of y equals 2 to the x, or f of x equals 2 to the x looks like. Now, some features of this thing, a very important feature in fact, is you'll notice it gets closer and closer to the x-axis over here. But it doesn't actually touch it. And what we're going to call that is we're going to call that line that it gets close to but never quite touches, we're going to call that an asymptote. So that's going to be an asymptote. So it's a line that it gets close to and never quite touches. Something else I want you to notice, looking at the graph, is that going from left to right, we're always increasing. So we're going to say that this graph is increasing. So it has an asymptote over there at y equals 0, and it's always increasing. Okay, now let's say I changed it up slightly, and I did. So now we'll do g of x. So let's say we change the base. So instead of 2 to the x, it's now 5 to the x. So I'll do the same numbers. What we get now put some lines in. And what we're going to get is we're going to get 5 to the 3, and 5 to the 3 is actually 125. 5 to the 2 is 25. 5 to the 1 is 5. 0, a fifth, a 25th, and 1 over 125. Now, if I graph this one, so let's put the points on. So 3 is already out of range, 2 is already out of range, 1 is at 5, 0 is at 1, and then it just plummets even faster down to 0. But it looks, if you look at it, the shape looks kind of the same, except it just flies up even faster. So this is the graph of g of x, which is equal to 5 to the x. Some important points. This one is still increasing faster. And we have an asymptote still over here. Asymptote, and the asymptote is at y equals 0. It's a horizontal line.